In this problem, because we don't have something that matches, we are going to make it match, and the idea that we're going to move forward with out of the three that were presented is we're going to take this bottom equation and we're going to make the y's match. We recognize that 5 does go into 15. Because 5 goes into 15, it's a very easy equation to work with. 5 times what makes 15? 3. But you can't just multiply one piece, you have to multiply the entire equation. It becomes like a full distributive property situation. So, what we are really doing here is we're adding one step to the elimination process. I will multiply all of these things by 3 to get 21x minus 15y equals 3 times 17 is 51. That means I don't need this equation in the middle anymore, and I'm going to do elimination with what I've just created. So there are my x's, there are my y's, and there are my constants. The y's match 15 and 15. But this is a positive 15, this is a negative 15. They are opposites. Should I add them or subtract them? Add them. By adding opposites, I end up with 0. I get negative 2x plus 21x to give me 19x. I get negative 32 plus 51 to get a positive 19. So I have 19x equals 19, which means x is 1. So that really didn't add very much to that process. The rest of this is exactly the same. Now that I know that x is 1, I can plug it into one of the original equations, or I can plug it into this new one. So I actually have 3 options. I can plug it into the 2 original equations, I could plug it into the equation that I created by multiplying. All 3 of them give you the same answer for y. I'm going to go ahead and plug it into the one that I crossed out, just because that had the smallest numbers in it as far as the 17 on the end goes. So that would give me 7 times 1 is 7, minus 5y equals 17, negative 5y equals 10, so y equals negative 2. So when it's all said and done, 1, negative 2.